Good morning, everyone. It's my honor to here for attending the FH stage. Today, we are excited to share our forwarding thinking insight about telecom infrastructure service and or some of our open source practice on edge computing. Let me tell you about a bit about us. I'm Tingting ZHANG service at China Mobile Research Institute, and I'm also associate director of ITUT, which is focused on the future networks, including functional architecture for computing. And I have keen interest in exploring the combination of standard and open source. And also joining me is my colleague Yanjun, who is also the participant about driving innovation in our field and an expert of open source. Okay.
Hello, everyone. Thanks for joining us. I'm Yanjun CHEN, and now I'm a senior researcher in China Mobile, mainly focused on cloud infrastructure and AI infrastructure. And I'm also deeply involved in multiple open source communities. And now I'm a FH Akrino technical committee member.
Okay, about the outlines, in this discussion, we will cover the evaluation of telecom infrastructure, dive into China Mobile's open source practice. Okay, nowadays, the telecom infrastructure is pivotal to digital transformation. Not only enable the communication required for digital interaction, and also it is significant contributing to the effectiveness of information service. As we look at the top 10s from Startups Insight, we see diverse business requirements of digitalization for capabilities in network, cloud, security, AI, and 5G, 6G, and also more. The chance towards hyper infrastructure and the distributed resource cannot be ignored, nor can the importance of service agility and flexibilities. Since 2021, telecommunication operators have proposed a new concept. We call it computing first network. This vision for the next generation of telecom infrastructure service is all about ubiquity in network, computing, and intelligence. CFN invents the future where computing power is fundamental and accessible, just as water or electricity. Just as your chain of type and expect water to flow, or flip a switch and expect light, in future you will be able to access computing results with the same reliability and immediacy. In this vision, computing resources are not just centralized, but are available at the edge, close to where we are needed. And this distributed approach ensures high latency and high availability, just as you accept water and electricity to be always on and quickly accessible. The key feature of CFN provides the computing and network service enabled by the high-speed telecommunication network and the uniform scheduling capabilities. It's about integration service of network, cloud, data, and AI capabilities, which is a great guarantees, providing a one-point access experience for users. So some research work we have done in the ITUT standardization organization, we have discussed a lot about the coordination of computing and network, which is an important enhanced for future network, and the requirements in the recommendation Y.3500 have been published. We just give the link. And also how to achieve the network first, computing first network. To realize it version, telecom infrastructure is involved by 3 lines, support this intent awareness, uniform operation, and the intelligent organization. From the bottom, the infrastructure layer, here For traditional way, just the computing the computing device or network is some kind of a network device. But here, integrated advanced components like in-memory computing, data processing unit, and innovation, computational routing device is being involved. So in that layer, computing and network converged infrastructure is a different kind of type. And the second layer, the organization and the management layer acts just as a network brain, coordinated resource by various controllers and applying AI-driven policies. This is a layer where CFN's intelligence is harnessed and management operations effectively. Finally, at the top, the unified operation service layer interface directly with users. Translating their intents into action is designed to meet users' need by providing us a seamless service experience. This is the whole picture of the CFN high-level architecture. And for the China Mobile, also is the largest operator in Asia. He has made significant strides in the infrastructure development, with focus on cloud and edge and terminal integration, heterogeneous computing resource, and multiple cloud operations. In the infrastructure, we have more than 10 EFLOPS capabilities and also 1.9 billion 5G base stations. And now we have longest 5G fiber network in China, more than 7,000 kilometers. For the distributed cloud, distributed resource, we already have more than 1,005 edge nodes. And we also offered the multiple cloud operation covered the AI data center, HPC data center, and also multiple cloud providers. Then we would like, okay, this is a general description about the architecture, the vision. Then we would like Yanjun to share open source practice to China Mobile. She will show how this CFN picture to be supporting by open source way. Okay.
Okay. So hope you're still with us, right? So talking about the vision is actually is computing first network is a quite big vision that the China Mobile proposed, seeing from us how we're going to provide our infrastructure service for our customers in many, many years. So of course, there are many technology breakthrough, technology upgradation should be done, should be tackled during this journey. So it's not a very simple work, it's a system of work. So typically, when telco tells about how to evolve their technologies, there are two typical ways. One is by standard. So standard is commonly used when is frequently talked about related with our network infrastructure, because we will set up the common view around our network functions related with the functions, interfaces, and also the sequences. So we're working together with vendors, manufacturers. So this is one typical way. And another aspect, such as cloud computing area, so this area actually open source is pioneer, advanced to the standards. It's kind of de facto standards in the industry. So absolutely, we need to embrace the open source ecosystem to do something. So seeing from us, we are trying to embrace open source in different ways in both cloud infrastructure and network infrastructure. For our cloud infrastructure, we will utilize open source technologies to do the cloudification, containerization of cloud infrastructure, and also when nowadays we know the AI application, AI services is booming, so we're gonna think about how to provide the better AI infrastructure for our customers as well. And of course, edge computing, we are improving our edge computing scale as well. this is about the software side, and related with hardware side, the communities like RISC-V or OTI, ODCC will provide more transparency or more openness of cloud infrastructure. So we will have an open ecosystem. So at the right side of the picture is about the network infrastructure. This is typically not the battlefield of open source, right? So it is very different. It's a very different way. So normally it's a standard battlefield, but we're still trying to do something related with new barrier network and AI data center network protocols, which we mean Open SRv6 and GSE. So this is a very general pictures that we have involved in different open source communities to help us to evolve cloud telcos infrastructure. And next several slides, we will give several examples, the project examples we have participated in. So first of this is XGVilla. It's a project initiated in 2020 in Linux Foundation Networking community. And this project's objective is trying to I think this project is kind of innovation to how our network function equipment, how our network function software are produced. So nowadays, vendors of Cisco's or Huawei or Nokia, when they help telcos to set up their telcos network, normally we will have software and hardware bundled together products, or even for the software products, it's not quite easy to have a multi-coupled equipments for us to extend the scalability or to open, to reuse. So that's why how XGVilla is proposed. So the main object of this project is try to abstract what kind of functions that could be reused in different network function products, such as 5G, UPF, 6G, or other telcos network function products. So XGVilla has abstract several common functions like network function configuration, topology management, performance management, alarm management, or log. These are the common functions that might be used in different 5G network or 6G network. See if we can do something to move forward, use a cloudified way to implement those functions. So in that case, in the future, we might be set up a PaaS layer that would have the better scalability and the better agility for our network infrastructure. So that's the purpose of XGVilla. And also we provide microservice framework enable CM, for example. So newly in this year, we have follow closely with CNTI, which is initiated in Linux Foundation as well. So we will see if we could in line with the CNF certification test suite for XGVilla. So for more information, you could refer to the website as well. So due to the time limit, I will not go to too much details for this project. So you could still approach me after this presentation. And another aspect is when telco's infrastructure evolve to hybrid architecture. So that means we will have multiple clouds, or we'll have more edge nodes, edge clusters need to manage. In that case, the management and scheduling capabilities become quite important and fundamental capabilities for telco players. So that's why there's a blueprint project set up in Linux Foundation at Rhino for verifying how ubiquitous scheduling capabilities would be performed to manage all these different level infrastructure in telco's network. So as you know, Rhino is set up to provide a lot of end-to-end reference architecture refer to different specific usage scenarios. So at that background, so that's why the ubiquitous scheduling BP is also trying to verify if this architecture works, if we deploy them in the real network. So there are a bunch of things we have trying to verify in the CFN BP project. First is if we deploy those different level of cloud clusters in different region, in cloud and in edge clusters, we could enable the global DNS steering functions. So in that case, when people coming from different places to request the service, we could direct them to the right places for the service. And also, if there's a fail of one cluster, if the failover could be recovered by the whole system. So this is one thing. And another thing is how to provide consistency in multi-cloud management and monitoring, as well as the service application lifecycle management. And these are handled mainly by a CNCF project named Kamada. Kamada actually is an open source project to manage the multi-cloud infrastructure. So we verify if this framework works in this real network implementation. And also with Istio, we trying to verify if service mesh works in multi-cluster. So of course, we need to have additional components like Submariner to establish the network connections between two different clusters. And also, last but not the least, the container scheduling requirements, referring to different usage scenarios. Actually, in this project, we involved a company, a service provider company who provide two types of service scenario. One is text-based emotion detection. It's an online text-based service. And another one is distributed cloud rendering. Actually, it's an offline video service. So in these two different scenarios, what different scheduling requirements are needed for our infrastructure. Actually, in this point, Kamada will manage how to deploy, spread all the service port in different clusters. So you can set up the weight, set up the percentage you need to separate the different ports in different clusters. And for each of the cluster, actually, the Volcano project will do the fine-grained scheduling capabilities offering. So you could have a batch scheduling capabilities dedicated for one service ports, with some spatial labeled enabled. Okay, so and also for the edge cluster, we utilize the Kuba Edge to be managed as one of the spatial cluster in this infrastructure. So to verify with this whole end-to-end implementation, if we could achieve the hybrid architecture scheduling capability in the cloud infrastructure of telcos. Okay, as well, you can refer to the website for more information as well. Another piece of work we started at the end of last year, actually. It's about, the name is AIoT. So we talk about the network function, we talk about cloud infrastructure, and now and now we are thinking about when there's an era of AI applications, what kind of capabilities or more framework we could provide for our customers, especially when there are a lot of IoT devices are involved in this ecosystem. People may need to configure a lot of environment, a lot of libraries or softwares back and forth. So it's a pain point for our developers. What we can do is the objectives of this IoT cloud-to-edge development framework. So basically, the key feature of this framework is offer a very simple YAML-like descriptive file to allow users to check binary libraries dependency and AI framework dependency, specifically when you deploy some, for example, the YOLO v5 algorithms to NVIDIA board, for example, and maybe you developer use your Python, you need to CUDA, you need to set up all the environments in the NVIDIA Jetson board, and maybe there's incompatible with different Python version, the PyTorch version, and a CUDA version. So there's very complicated work to do. So basically, this framework will offer you an API to check all the dependencies, and even for necessary, the libraries will be packaged together for different IoT devices. And also, it will allow people to orchestrate the service components across cloud, edge, and terminals devices together. That means when we are doing some usage scenario that we need, for example, training at the cloud side, inference at the edge side, or terminal side, you could use one file to orchestrate them very easily. So this is a key feature provided by this framework, and also to be extendable, we also provide the integrated library, including the AI algorithms library, datasets library, and the resource management library. People can use the API to extend their own AI algorithms and datasets as well. And of course, there's one important functions is how to work with those different types of terminals like NVIDIA Jetson or Raspberry Pi is currently this framework offered. But definitely this part is, I think we could utilize the legacies of edge projects. I think there's a lot of projects trying to do this layer. We provide an abstract layer or broker layer that will talk to different devices at the southbound. And for the northbound, we will have a unique view for the service application. This is, I think we could, in the future, integrate more open source project to improve it. And also the protocols as well. Currently, the MQTT, HTTP, HTTPS, etc., those application layer protocol has been implemented. And also with this framework, you don't need to build everything from scratch. I mean, for the communication side, so all the message transformation has been handled by this framework, including the redundancy, retransmission, and also the scheduling between the cloud nodes, edge nodes, and terminal nodes are capable as well. So we are thinking about to open this project to the open source community. We're still in a discussion with community. And another project I like to mention here is actually it's also related with AI, but it's will become a very common, it's a very common requirements when we are facing different types of architecture of AI chipsets. For example, if you have NVIDIA chipsets, GPU, or you have Google TPU, or you have Huawei NPU, especially at the edge side, there are numerous types of accelerators we will face in the future. So in that case, so current development model will have a very big issue is when you develop an AI application, for example, use Python, use CUDA, framework, it cannot be transferred directly to the TPU or NPU chipset. Normally, you need to rewrite the application, and you need to adapt to CUDA or adapt to one API or etc. at the runtime. So you need to then you could able to transfer the AI applications. So this project has been initialized in the Open Infra Foundation. We call it computing native technology. So the objective of this project is trying to handle the challenges of migration over different architectures accelerator. So generally speaking, there are three key components are covered in this open source project. First is we're trying to use uniform language to transfer different programming models. For example, the programming models based on the CUDA, based on the one API. So nowadays, we utilize the SQL to transfer them. Since SQL is a cross-architecture C++ language, so it has very basic and fundamental capabilities that allow us to migration in between different devices. So for this key layer, we will do the transformation from different programming model to SQL, and also to easy the way, a tool would be provided to allow users to quicker transfer if you don't want to write the AI applications line by line. And another big part of it is the unified device abstraction. So if you are facing different architecture chipsets, especially at the edge side, there are numerous chipsets. But for the AI application, for the AI programming model, they don't want to see a lot of different capabilities of chipsets. So what we can do is to abstract a virtual device logic model, which this model talk to the same language, they can understand each other. But for different accelerate hardwares, they will have different configurations. So in that way, so with unifying programming model written by CQ with virtual device logic model, they know how to handle these CQ AI applications to the virtual logic devices as well. So we solve the problem of the northbound. And for the southbound, actually, we cannot do things with virtual, right? We still need to handle the dirty work. That's either southbound to translation between this virtual model to the real different architecture of the edge devices, edge accelerate devices. So that's how the adaptive runtime library work. So it allowed open interfaces for dynamic registration of different architecture chipsets like CUDA, like ROCm, accelerators, XREL. So these are the key components could be provided by the cloud native subgroup open source project. And also we are very welcome more chipset company or framework providers join these projects, so we could have the very open ecosystem to allow this framework can migrate over different systems. Okay, I think that's all for this part. Yeah.
Okay. And just as Yanjun mentioned, we have some open source practice and some very interesting project. And besides that, we also established a CFN innovation test infrastructure. We just we just call it safety. This infrastructure is aimed to verify new technologies integration, promote some open source best practice, and include some new applications. Just as Yanjun mentioned, cloud computing, IoT project, etc. And safety has over 10 diverse computing resource pools in China, covered 8 high-speed links and 1 link connected to overseas. It is in this core center in Beijing. We have 20 libraries of CFN and open more than 20 test suites, such as multiple community testing, IoT developing framework and testing, and also CI/CD for intelligent network, etc. This is an open platform for innovation. And safety primary goal is to serve as a rock-set testbed for the integration and the verification of new technology. It is where we just put your concept and some code to practice test in insurance that they meet the IGNOU standards required for real-world application. And also, it can commission to open source best practice, we actively engaged with communities like OIF, LFE, and CNCF, practically participate in open source to ensure that our innovation are not only cutting-edge and also elegant to the collaboration to the open source development. In addition, technology verticalization safety also play a significant role in fostering scientists and technology experiments. It is a sandbox we open to researchers and developers can freely explore, experiment, and to open some new ideas here. Based on the safety, we also host some hackathon compatibilities for 7 or more than 100 industry teams have been involved and have some brilliant idea here. Okay, this all for the safety. Anyhow, safety is more than just maybe for future. It's more than just a testbed. It can also providing a ground for new technology and a platform for collaboration. We will see instance and potential in expanding our collaboration with open source project to accelerate the development and adoption of certain technologies. So in conclusion, open source, I think, is indeed a hotbed for practice, and it plays a critical role in making the convergence of computing and the network more smoothly. So we believe that through collaboration and innovation, we can drive the future of technology, telecom infrastructure service. Okay, thanks for your attention. Any questions? Because it's nearly to lunch. Okay, it's open question.
The CFN seems similar in objectives in part to the Modular Accelerated Execution Platform. Are you familiar with that project? And have you had any engagement with them? It was started from the LLVM, it has heritages in the LLVM compiler chain. And they have developed a language called Mojo, similar to Python at the top level. And at the bottom level, they've developed Max, which is a API layer for distributed AI computing, including edge devices. Are you aware of them, and have you had any correspondence or? It's commercial and open source, I think.
What's the name?
Modular. If you go to modular.com, their platform's called Max, and it's a modular accelerated execution platform for AI workloads. And it sounded similar to the work that you're doing here. So I just wondered if there'd been any collaboration.
I haven't heard about this, but thanks for your information. We will definitely go.
Okay. Thank you.